So what does it mean to accelerate? We talk about that all the time. Well, in physics, acceleration is the rate at which you increase your speed. You're either going to increase your speed by the same amount every instant in time, or it can be decrease your speed, because really it's your change in velocity over time. It's how much your velocity changes each instant in time, or your speed changes in each instant in time. So whether you increase or whether you decrease, in physics we call that acceleration. A really good way to represent motion is to imagine a car that's dropping oil on the ground. And as it moves across the ground, imagine that it would leave dots. So remember the definition of speed. Constant speed means you travel a constant distance, the same distance every instant in time. So when you look at these three diagrams, which of these do you think would show constant speed? Diagram A, where you start further apart and you get closer. Diagram B, where you start closer and you get further apart each second in time. Or diagram C, where they're all equally spaced. You'll probably guess diagram C. So this is called a dot diagram. It's a really good way to visualize constant speed and acceleration or deceleration. So the constant speed here would be represented by diagram C. Now let's take a look at B. The dots start closer together and then they get further and further apart. So the only way for that to happen would be that you're getting faster, right? Because speed, constant speed, means you're traveling the same distance each instant in time. If you increase your speed, you would travel further each instant in time. So imagine that this car is going to the right. As it goes to the right, the dots get further and further apart because it's increasing its speed. Now let's look at diagram A. Diagram A starts with dots further apart and then they get closer and closer. What do you think that represents? If you chose deceleration, you're probably right. As long as the car is moving to the right, if it starts traveling and the dots get closer and closer, then that means it's slowing down and it's traveling at a slower speed every instant in time and it can't go as far. So it's slowing down as it moves to the right. But there's another way to look at this. What if it were moving to the left? If I told you that the car were moving to the left, then it would be accelerating to the left, right? It would be getting further and further apart as it goes to the left. If I told you that the car in diagram B was moving to the left, then it would be the exact opposite. It would be getting slower and slower. And C, it wouldn't matter whether it was traveling left or right because it's traveling at a constant speed. So the dot diagram's rules of thumb are, if dots get further to the right, it gets faster to the right. If dots get further to the left, it's getting faster to the left. If dots are the same distance apart, they're traveling at a constant speed.